Hello, my name is Song Chan-jun. I'm an instructor of Discrete Mathematics. This is the textbook and references, and for this Discrete Mathematics class, the main textbook is lecture note, and also additional textbook, then Discrete Mathematics and its application, the 7th edition, written by the Kenneth Rojan. So also we have three the references, the Handbook of Discrete and Combinatorial Mathematics, also written by Kenneth Rojan. This is a really thick book, and maybe you can keep this kind of book for your future references. That'll be good. And also for the number theory, then hopefully you can try to see this kind of elementary number theory written by the Untitled Chapter, and also another Discrete Mathematics, the reference book could be written by Rojan and Biggs. So for the reading material, I recommend to read this kind of book, 9 Algorithms That Change the Future. Yeah, this is a really interesting topic. This is the recommended the book for the computer scientist. And so there are many interesting topics, roughly 11 topics exist. And then among these, maybe phase length, and then public key cryptography, and then the pattern recognition technique and something else. Yeah, that is a really well written and then easily read. Okay, so I recommend the English book, also the Korean book as well. Another reference, the reading material is A Future Mind, written by Richard Watson. Then nowadays, we don't know how the future is going on. Then hopefully you can try to read this book and understanding how things is gonna change in the near future. What is discrete mathematics? The discrete mathematics is a mathematics dealing with a discrete object. So discrete object is such as integers, graphs, and statements in large. Why discrete mathematics is important? You're using the computer, but your computer is a common digital computer are based on the discrete bit. Okay, so your both computers structure and also operation can be described by the discrete mathematical expression. So when you work with this kind of computer, you should know how to speak their own language. So in the discrete mathematics, one interesting topic is cardinality. So cardinality means your given subset, given set, cardinality is number of elements. So commonly, the number of elements is a finite or infinite exist. Maybe you know, but think about the infinite world. The infinite world is not as simple, or some kind is a magic exist. This is a very interesting. The concept here is the Hilbert Grand Hotel. The Hilbert Hotel is there's no vacancy room exist. Okay, then the room is already occupied by the person. Then the new person is coming. Then this new person is possible to assign the vacant room. In the finite world, it's impossible, but in the infinite world, sometimes it's possible. How? Like this. The first room occupant move on to the second room. Second room occupant move on to the third room, and keep going on that way. Then one room is empty. So now newcomer can go to the room 1. Then it's possible. Wow, looks like it's a kind of nonsense, but it's kind of the paradox, showing something impossible with the finite world may be possible with infinite world. Yeah, so this is a kind of something magical in infinite world. You'll see this kind of topic in discrete mathematics. So another interesting topic in discrete mathematics may be the rigid problem. Okay, so triune remainder theorem is a really well-known theorem. Yeah, simple question like this: there are some certain things whose number is unknown, but when divided by 3 and remainder is 2, when divided by 5 remainder 3, when divided by 7 remainder 2, then what will be the number of things? Mathematically, you can explain like this, x, and this is the congruence concept here. Then x and congruence 2 under modulo 3. What does it mean? Yeah, here like this. A and B and congruence under modulo M means the A, the minus B can be divided by M. Then A and B is called are congruent under modulo M. What does it mean again? If we try to divide by M, then remainder of A and remainder of B the same. They have a same remainder when you divide by M. That is called this kind of expression. So based on the concept, x divided by 3, then remainder should be 2. X is divided by 5, remainder is 3. X divided by 7 and remainder 2. Then this kind of the system of a congruence equation can be satisfied. Then you have to find what is x in the sense. Yeah, you see, yeah, if you try to think about a little more carefully, you can get some solution easily. But general concept like this. How about this? The given n the system equation. Okay, then how to find solution x. Yeah, that is called the triune remainder theorem. We'll discuss this kind of concept in this. But another very interesting topic is cryptology. Yeah, cryptology is a kind of the secret information generation idea. And then classical cipher is usually we have the final exam. Yeah, in June. Then, in the sense, then how to make this kind of statement, as the secret message. This is a simple idea, classically idea transposition. So we try to write down individual letter and then this kind of word and this way, and then list up. Well, how about this? This way and this way and this way and this way and list up. Then this looks like a secret message. But if you understand how this message is generated, then you can easily decode this kind of message. That's called the classical cipher. Another idea is maybe for individual the letter and then they generating some the special shape, the code. Yeah. So instead of alphabet, then this special code they use. And then if you understand this kind of the generation concept, then you can decode this kind of idea. This is called substitution pre-Mason. Among this, public crypto system is generating by the integer prime number. So that is called RSA system. So we'll discuss how to RSA system is generating from the really huge large prime integer. Another interesting concept is the graphs. Graph is sometimes the main topic in discrete mathematics. Graph is a really well-known discrete structures consisting of vertex and edge, the connecting these kind of vertices. Simple example is highway map. Yeah, it looks like a highway map. The city is called as a vertex, and then between cities, the connected highway is think about as an edge. Also, how about flight map? Looks like this. It's Korean Air flight map. It's the hope Seoul is exist, then from the Seoul, and then which country can be the flight schedule exist, and then you can think about this kind of vertex and edge expression. So very interesting. The classic question is maybe 7 bridges Königsberg. Yeah, this is the 7 bridge exists in the Königsberg city, and then but the simple question is here: is it possible to travel across every bridge without crossing any bridge more than once? Only one time you can cross the bridge, but you have to find: is it possible to travel across every bridge? Yeah, that's a simple question. But how to solve this kind of problem? Then the graph idea can be usually used. This kind of expression can be changing this kind of graph expression. Then within this graph the expression, then you can try to find the maybe Euler's the circuit or Euler's path. That's a simple question here. We'll discuss this idea as well. But very simple idea also with graph coloring issues is usually maybe you know this kind of world map. So yeah, individual the so common border area is country, they try to color it with a really different color because to separate it. This Russia and Mongolia should be separated. They try to color it in the same color, then Mongolia and Russia cannot be separated. So that's an important issue is they have a common border, then color should be different. Then how many colors required to draw this kind of the world map? That's a simple question also. Okay, this year 2021 spring semester, Discrete Mathematics gonna held Monday and Wednesday from 4 p.m. to the 5:20 p.m. This class would be online until special announcement is made. However, exams would be determined later. Anyway, the first class will start on March 3rd. Let's see at June